Hi everyone, welcome to trigonometry. Today we explore lesson 15, vectors. Number one, vectors. Definition: a vector is the quantity having both magnitude, length, and direction. So this is called a vector. We have an initial point A, and we have a terminal point B. We can connect A to B using a straight line with an arrow. And what we have is a vector V. The vector V is also the vector A to B, or AB. There are many examples of vector, such as velocity, weight, force, magnetism, heat, pressure, and many more. To define vector addition, let's take a look at another definition. Two vectors are equivalent if they have the same magnitude and direction. Now, let's take a look at vector addition. Well, let's say we start right here. This is the first vector, u. And here comes the vector v. This is where we end. Then we have a vector that goes from start to end. And that is the vector u plus v. Well, we can move the vector u to this side. Equivalent, same magnitude, same direction. And from here, we can also get the vector u plus v using a parallelogram. There are two ways to do vector addition using triangle. Or we can use parallelogram. Pretty cool, huh? Well, we also have another operation with vector. Let's call it a scalar multiplication. Scalar multiplication is the, let's say that we have a vector v right here. This is half of v two v negative 1v. So what we see is that we have a constant or a scalar c times the vector v, where c is a real number. Well, we use c to scale vector v. Let's move on to two vector components and vector operation. In the xy plane, let's say we have this A, this B, right? Then this is the point P equal AB. We can always get a vector from the origin to this point. And this is the vector OP. Let's call it a vector V. And we write it as AB, two components, the X component and the Y component. Another way we can write this is AI plus BJ, where I is the vector 1, 0, and J is the vector 0, 1. This is the basic in R2, the plane. Well, they are the same. Let's take a look. A vector I is 1, 0. B vector J is 0, 1. Well, in order to show that they are the same, we just have to distribute A. A times 1 is A times 0 is 0. B times 0 is 0, B times 1 is B. And, well, to get the vector AB, it looks like we have to add A to 0 and 0 to B. That is, we add them component-wise. So this will give us A, B. Pretty cool. This little example also shows us that that is how we define vector addition. U is A1, B1. V is A2, B2. Then U plus V is A1 plus A2, comma, B1 plus B2. We also have a definition for scalar multiplication. C times A1, B1 is the same as CA1, C, B1. Pretty cool. Here comes an example for the sake of this one. Example. Let U be 1, 2, and V be -2, 3, 5, U minus 2V. U minus 2V is 1, 2 minus 2 times minus 2, 3. 1, 2 can distribute the number 2 in, or you can distribute -2 in. I'll distribute -2 here. -2 times -2 is 4. -2 times 3 is -6. And then from here, we add them component-wise. 1 plus 4 is 5. But let's just do this one step and let's not skip it. 2 plus -6. This gives us 5 and -4. Let's move on to 3. Magnitude of a vector and unit vector. The magnitude of a vector is the length of the vector. So here come the magnitude of a vector v is either absolute value v or this one, double absolute value. We call it the norm of v. And it is defined as root of a square plus b square plus c square. Yeah, just how long the vector v is. If we take the vector v to be OP, then the distance from a point to the origin is exactly a square plus b square plus c square, square root of that sum. Definition: a unit vector is the vector having magnitude of 1. U is equal to v divided by the magnitude of v or the norm of v. And then you can also use the other notation. It's the same thing. Whichever fit you. Let's do an example. Example. Let vector A to be 1 minus 3 and B to be 4, 1, 5. The magnitude of A minus B and a unit vector in the direction up. The vector A minus B. Ooh. First is let's do the magnitude of A minus B, which is the magnitude of 1 minus 3 minus 4, 1. And this is the magnitude of 1 minus 4 is negative 3, minus 3 minus 1 is negative 4. So that is the square root of minus 3 square plus minus 4 square, which is root of 25, and that is 5. A unit vector in the direction of the vector A minus B is the vector A minus B over its magnitude. The vector A minus B is minus 3 minus 4. The magnitude is 5. So this gives us minus 3 over 5 minus 4 over 5. That is the unit vector. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. I will see you in the next video.